This video is about thread milling. We're going to start with a simple cylinder with a hole. Nothing fancy, just to show thread milling on a mill. It's a 2-inch cylinder. We're going to extrude it -2 inches. We'll make a 1'8". Let's make a 1/2-13. Don't remember the hole size for a 1'8". 1/2-13 is 4/37 hole. We'll extrude that. One-inch. We'll put a little chamfer on here and make it 80 thou. Alright, so we have a hole. We don't have to call it a thread. Down here in the create drop down, thread, we do not have to make it a thread just to thread mill it. And that's for design or something else. For manufacturing, we've done all we needed to do. From here, we'll do a new setup. We'll change our stock to a fixed size cylinder, 2" by 2". We're not really worried about the post. We'll just name it 11. Our setup: Z-axis top, X-axis there. Doesn't really matter on a cylinder. Press OK. Now let's make a center drill and a chamfer as quick as possible. There's a tool, center. I guess we're not going to get a filter here, so we'll start one from scratch. Hole making. There it is. Center drill. It's missing it. Number 2. Center drill. Easy. That's fine. Tool 1's fine. We don't care about the rest. Select. Now just select the geometry we want to machine. Go to our heights tab. I like to put everything on selection or model top. We're doing selection at this time. So clearance height here, retract height from here, feed height from the top of the part, top height from here. The whole bottom, I like to make it either selection or whole top. We'll do whole top just to show you. That means that whatever hole we have selected will come from the top. Even if you have a chamfer there, you'll get 80 extra thousandths. So all that's set. In the real world machine shop, you want a 1-inch clearance height, a 1-inch retract just for basics. Feed height, we don't feed from 200, we feed from 100 or less. Top height is going to be 0. A center drill number 2, which is I believe 3/16 diameter, can only go 3/16 deep, so we'll make that 188 deep. And we'll look at this part. Going from the hole top, that shows that our center drill is going pretty deep past the cutting edge. It doesn't need to. We'll change this to selection. Select the top of the part. Now our center drill is going much shallower. Now I would make this about 160, just to get close to the cutting edge. That's all you really need. Next, our cycle is drilling in, wrap it out. Not worried about linking, press OK. We got one tool set real quick. Fastest way to do the next one is right click, duplicate that operation. We'll go to edit and we'll select the tool and modify the tool. Now we need a drill, pretty easy. 7/16 drill, cutting data. We'll leave that alone. You can figure out what you need to do for whatever material you're on. Post processors 2, press accept, select. Now these speeds and feeds are ridiculous. We really don't care, we're just doing thread milling. We're trying to do the geometry or the toolpath of thread milling. Everything that we have is selected. Bottom height, I would make this the same selection, except it would be 1 inch deep. And I would make it drill tip through. That way the cutting edge of the drill is actually 1 inch deep, not the point. Cycle, it's going to be deep drilling. We want to peck. We don't care if it's 100 or whatever right now. We're going to make it 60. None of this really matters. We're just doing the thread milling. Alright. Right click, duplicate again. Edit. We're making a chamfer. New tool. Countersink. I like a 1 inch countersink as a standard. 1 inch 90 degree chamfer. In this case, I do not like to have a tip. 0. Change this diameter to 1. Shaft is usually 0.5, doesn't really matter at this point. Again, tool 3, press OK. Now we want this height to go to all of our clearance or retract, feed, top heights all set, because all we're doing is duplicating operations. We're just worried about the bottom heights on all of these. So in this case, for a chamfer, we want to go to a chamfer diameter, and I like to go 10 thousandths per side over our nominal thread size. So half 13, we're going to go 520. 2 chamfer diameter, 520 thousandths. Press OK. Even though our chamfer's on here, it's not the same. In real life, you can adjust it to what you need. Okay, now we'll get to the thread milling. We'll come up to the top, 2D, thread. We're creating a spiraling helical cut. Press OK. We have to make the tool, new tool plus, then we will go to thread mill. And in this case, you can use a Harvey thread mill in the Harvey library, whatever is standard tool. We have a 7/16 hole, so we're going to make a 3/8 diameter thread mill. So 3/8 die, 13 TPI thread mill. You go to the cutter, change that to 3/8. Change the shaft diameter to 3/8. Let's go with 300. Overall length, 2 inches, doesn't matter. You have to set that for your own tool. Shoulder length, flute length, doesn't really matter. Thread pitch, 1 divided by 13. You don't have to do math here. If this is going to be a single tooth thread mill, you have to go to the bottom of the hole and mill all the way out to the top. If it's a multi-flute or multi-teeth, you only have to do 1 lap or 2 laps, depending on how deep your threads are. We can make this, you can also lie to it, and you can tell it it's a single flute or single tooth when you have a full. You'll see in a minute. Cutting data, we don't care. We'll just make that 100. So the speeds and feeds are not crazy. Feed per tooth, tooth out. Again, adjustable for whatever you need. This is just for toolpath. Press accept, select. That's going to go in the hole with clearance. All our speeds and feeds are set. We don't worry about that. Circular face. Select the 7/16 hole we made earlier. Height. Select selection. Top. Let's say we want to go down 625. You can see our heights are here. Clearance, selection, top of the part, 1 inch. Retract height, selection, top of a part, offset 1. Top height, we're going to make that a selection, not the whole top, right there. That's done. Start angle 0. You can start at whatever angle you need. It'll start clock whatever you want, 90, 180, 270, in between 22.5, doesn't matter. Pitch, diameter, offset. You can adjust that if you need to. For me, I leave it alone. Compensation in wear, or else you guys cannot adjust the offset. It won't output a D offset for your code. Now what else are we doing here? We have, if you look in the hole, you have 1 path and some weird movements with your linking. This vertical radius, that's useless. Change it to 0. Linear lead in, it's good to mess with. Horizontal lead in radius, you don't need the radius, it helps. These two, they can probably be 50 thou at this point. Much smaller clearance if you have smaller tools. Now we're doing 1 path. You can see the tool path there. We can change this. Press OK right now. If we go to the tool, edit the tool, go to the cutter, reduce the number of teeth, press accept. Will we get the same thing? No, we get more passes here. A good trick to do in this case, we'll change our cutter to have 1 tooth. In real life, you can have multi-teeth. Press select, press OK. Now it wants to go from the bottom that we selected, 625, to the very top. It's a lot of passes. See those passes right there? Let's change the top height to 2 threads, 2 passes. Half 13 pitch is about 76 thousandths, so 150 thou. So we make that minus 0.475. It's 200 thousandths. No, 150. Press OK. Now we get 1, 2. That's all you really need. You don't need to over thread something, wear out a tool. That takes 8 seconds at these speeds and feeds. Of course, you do not want to take that full depth every time. So you come in here and you do multiple passes. Now you get number of step overs. I like to make it, if we're dealing with carbon steel, 5 thou. Now it shows us 2 passes. Let's do that real quick. 4 passes, 5 thousandths each. First pass is going to be deep. The rest of them are going to be 5. Press OK. Now you have a cycle that takes 30 seconds. You think you can do that with a tap much faster? Probably. Let's say you're dealing with stainless steel or duplex. Your tap breaks. Now you got to take that to a manual if you can, just to get the tap out. If you thread mill it, you just got to take the thread mill out. Start all over. It will catch the same lead. That is it. Let's look at the post. And let's use Haas Next Generation. Let's make a folder. Desktop. Tutorial. G-code. Create. Open. Units. Configuration. We don't need any of this. Let's just post it out and see what it does. Except we didn't get code, so let's change this and open CNC editor. Now we have code. Here's our drill. All these end numbers are useless. Center drill, drill, chamfer, thread milling. You see it goes down. Read your code. It drops down 634. If that's deeper than the hole is, if that's at 1 inch 600, that's a crash. Read the code before you run it. That is it. I hope you enjoyed it. Give a like and subscribe.